So I will start this conversation by saying I know nothing about chemistry. Okay. So please don't ask me any difficult questions. I've been working in IT and specifically around biometrics and AI and all the current technologies for quite a large number of years now. And I've been working at Johnson Matthey for 18 months. And I came in as the IT director there, looking at how we can digitalize Johnson Matthey. And Johnson Matthey are going through a massive journey of transformation in terms of adopting digital world. So I just want to give you a little bit of overview of what we do, who we are, and how we are using AI, artificial intelligence and machine learning across Johnson Matthey to really change the way that we work as a business. So I'm not going to read the slides for you. You can all read those yourselves. But the Johnson Matthey has a long history in the chemistry world, as most of you know, I'm sure. And looking at various technologies around metals and chemistries around that and how we clean the air and use catalysts and so on. Like I said, I'm not chemistry based, so I'm going to use words that I don't understand. But the interesting thing that attracted me to Johnson Matthey as an organisation was something that CEO Robert McLeod said just last week. The time it's taken me just to have those slides on the screen there, just skip through very quickly because it bore you with Johnson Matthey's history. But we've actually stopped 40 tons of pollution from entering the atmosphere in that last minute and a half. Okay, and that's something that, as an industry, excites me greatly. So I'm really, really, proud to be part of this industry now. So I'll stop with that enthusiasm around our company. So as you know, this is the sort of thing we do. So I'm just skip through that. So history of AI. Johnson Matthey is using AI, and so I just want to give you a little bit of history about what we do. AI is not a new technology. It's not a new thing. It's been around for hundreds of years, and in recent history, Mary Shelley's Frankenstein book discussed the use of an artificial intelligence, Frankenstein's monster, and in real practical terms, Alan Turing really considered as the sort of father, if you like, of the technology, using it to decode the Enigma codes. And then sort of moving into the 50s, Dartmouth College, you had John McCarthy who coined the phrase artificial intelligence for the first recorded time, possibly before that, but that's certainly the first documented time that we know about. And it had a fairly steady growth through the 50s, 60s and 70s. And then there's quite a plummet as funds took a bit of a nosedive and the enthusiasm around artificial intelligence and machine learning really, really waned across the globe. And then Stanford University really kicked off some more work, and then IBM and some of the big players got involved and started looking at how we can use it to do what now seems like quite trivial things, but basically play chess, checkers, Go, those sort of things. To a point where we are at the moment, we have AlphaGo has been the world number one 4 times out of 5 at Go, for example. We have Elon Musk is creating OpenAI, has published OpenAI as a technology. Google, Microsoft, we've got the Xbox 360 is now a consumerized product. You can have AI in your home for very little money. So as you can see, it is massively increased in terms of usage and the investment put into it. I'm going backwards, sorry, wrong way. A few definitions. So, what is artificial intelligence if you're not sort of very aware of the terminology? So artificial intelligence really is about how we can take things that computers can do that we thought previously only humans could do. So it's about that intelligence that the computers can generate and provide for us. I don't particularly like the term artificial intelligence. I prefer augmented intelligence because I see the way that the AI provides, and certainly within Johnson Matthey, is it's augmenting our intelligence. It's not supplementing or replacing the intelligence of the humans. And machine learning is really about algorithms and how machines can adapt through their understanding and learning as they go through. And these are important concepts to consider when you look at how you apply AI and machine learning to your organisation. Some patterns of AI. So AI and machine learning really falls into something that Cognitive World published this year, which I thought was a really nice picture. It shows fundamentally the 7 patterns or attributes of what AI does. And any system that you provide that provides artificial intelligence into your organization really falls or collects one of these or more of these patterns or collectives together. So you might do something that's say video analytics, for example. It has some recognition in there. It takes videos, it captures and recognizes the world. It identifies parts of the video feed, and then maybe it does some pattern and recognition and acts on those on anomalies, like it recognizes a bag sitting in the corner of a room which shouldn't be there. So that's an example of where AI would assist through video analytics, and it's using 2 patterns there. So again, that's just sort of a backgrounds. This is all useful information, but really how do we use it? So in Johnson Matthey, here is just a collection I just grabbed of things that we are doing right now in Johnson Matthey, utilizing AI and machine learning. There are probably 5 times that many in reality. I could show you a whole long list, but I just wanted to pick a few here that seem relevant. And AI and how we're using it within Johnson Matthey really falls into one of 3 camps. We have R&D, which is really adopting AI very, very heavily. They recognize artificial intelligence and machine learning as being a real value to them. Very early adopters see the benefits straight away, and I'll talk about that in a little bit more in a second. Then you have the production and manufacturing side, and they're kind of reticent, I guess is the best way of putting it. Don't trust machines. Don't trust people to do machines to do better things than the machines can do, or they can do. Sorry. You have plant managers who've been running a line for 30 years. They know every single nuance of that particular line, and they know if they tweak this and up that and move that, they can make it very optimal. Don't believe a machine can do it better. That's been a challenge, but we are making progress where we are running things in parallel at the moment for things like line optimization, and we can show that actually we can show you with a little bit of tweak we can get 1 or 2% improvements on the quality of the end product. Now that some places that doesn't really matter. Some places it makes, it's £1 million a day of extra product going through the line. So that's coming along. But where we are seeing areas is things like digital twins, and we're creating digital twins of all our factories. And a digital twin, I don't know if you know or not, but digital twins basically is taking the physical world and putting it into the silica world. And it's looking at how we model a factory, for example. And a great example of something we did, we needed to move a big washcoat barrel from one floor to another floor in the factory. Didn't know if it was going to fit through doors, past machines, etc., etc. We could have just sort of lifted it, measured it, hoped for the best, and sort of shoved it through on a trolley. We created a digital twin of the factory, ran it through, worked out the best route through the factory to get to where it needs to be, and that saved us huge amounts of time. And these things are, sort of 5,000-gallon drums and very large and heavy, so obviously they're quite costly to move and get wrong. What we didn't want to do is get up to a doorway and have to knock a wall down. So that was the first example of where we used it, and now we've got a digital twin of that factory. What we can do is we can now say, well, actually, maybe we can optimize our production line a bit better. Maybe we can move the warehousing somewhere else. Maybe we can do this, and we can model that factory in a different way. Video analytics is another great example, which we're working on, which is looking at near miss. You have the real EHS world where you see incidents and problems come up, but where we're seeing video analytics is we're capturing the videos, live feeding it through into the AI machine and the machine learning, which then identifies where a near miss happens. We identify a near miss and say that person walked behind a forklift very close. No one spotted it, but it was a near miss. The machine then understands and recognizes that, and the next time it identifies that there was a near miss. And so that's how we're utilizing that AI in that space to help us improve the safety of our workforce and across the factory. The third area, if you like, is in the corporate space, and RPA, robotic process automation, is somewhere which is really helping us in that space. Video analytics less so, predictive maintenance less so, but certainly where we want to automate standard tasks, mundane tasks, financial close, consolidating 500 Excel spreadsheets. As everyone knows, the whole system works on spreadsheets. So bringing 500 spreadsheets in at the end of the month, which are all in slightly different formats. Someone will say 1G, one will say 1 gram, one will put 1 and then a gram next in an Excel. All those kind of things that everyone has to manually fix. Run those through an AI machine, off it goes, normalizes the data, gives us a financial close within seconds rather than days of people doing work. So we're seeing real benefits of improvements in there. But that's So production and corporate AI and machine learning really is about efficiency. When we talk about the chemical side and the research side, it's really about innovation. And so this is where we're seeing the biggest adoption within Johnson Matthey and certainly the biggest transformation. So these are just some areas. These are a couple of slides from my chief scientist. So like I said, I know nothing about chemistry. Please don't ask me any questions on these 3 slides, please. But fundamentally, she did talk me through it. So fundamentally what we're seeing in terms of our use of AI is about digital twins and modeling. It's about identifying white space, identifying areas of unknown and unpredictable challenges. And as was mentioned a little bit earlier, it's narrowing down the mass into something where we can focus our attention. And then it's that massive amount of data that goes through and mining and looking through that data and identifying common patterns or areas where we didn't realize there was a pattern and moving forward on that. A big area which at the moment is a hot topic for us, which is about that complex data structures of unstructured data. Reports, past papers, research papers, either in digital or on just in scanned or paper format that we can scan in and so on. And it's trawling through that paperwork, and it's doing 2 things. One of them is searches, so we can just look for things in a quicker and easier way. So that's just about simplifying my life, really. But then it's about, okay, we apply AI onto that and machine learning into that space, so that allows us to narrow down and identify where those areas of interest might be. And then we look at something like we trawl Google, for example, and look at what the world is doing. So this is the voice of the customer without actually knowing or speaking to the customer. So we're looking at Twitter, we're looking at Google, we're looking at all the various other social media sites and seeing, well, what's the world talking about? What is everyone really worried about at the moment? And identifying, I mean, that's a huge amount of data and volume in there. And then trying to identify from that, well, what are the trends? What are the things that we need to focus on within our science? And sometimes that gives us an area where we think, you know what, that's obviously going to be a thing. Let's go and look at that. And then the other area really is around the mass amount of data around the different scales that we look at. And so here's a few pictures. Like I said, I don't really understand what they're doing, but fundamentally we have sort of fairly high level scale of our substrate at the top there. And we do X-rays at that level, and we're going down lower and lower and lower until we can see flow modeling. Now those 2 actually are supposed to be animated. One of them is and one of them isn't. But they're very, very low resolution versions of the originals. And I'm sure you know much better than I do about what they do. But for example, the data on the flow model picture on the bottom right there is about 2 seconds of flow at very high resolution, and it takes up terabytes of storage space. Okay, just for that one picture, and we want to do that across basically something which is sort of about that big. So you can imagine the scale that we're trying to work on, and where that is looking down to about sort of 1 millimeter of cube, right? And that's a challenge that we can't yet achieve, is modeling a 1 millimeter area of our space. So the mass amount of data there takes someone decades to trawl through, and where we've used AI is really to analyze that data, take away all the white noise, look at the areas of focus, and just really focus our engineers and our scientists on the right areas. And these are the 2 words that my chief scientist told me to say. What AI does for them is it allows us to innovate faster. Okay, fundamentally that's it. As far as she's concerned, that's the power that AI brings. And it is something that, whether it's through efficiency or through identifying new areas of science that we hadn't worked on, or just working through all the noise, at the end of the day, it allows us to innovate faster, which means we can come to market faster, which means that 10-year life cycle of thinking about something to productionize is just shortened dramatically. So I want to talk about a few myths about AI, which you might have heard. So AI and ML science fiction, we've all seen the movies and how AI is, HAL in 2001 and so on. Well, it's been around for a very long time, at least as a concept, but it's been very, very real since 1939 at least, and it's in everyday use around you. Any smartphone you have on you will have Siri and Android and so on will have on there Google Chrome, Twitter and all these other tools, all using AI in the background, some more than less than others. Some of them are still using humans to pretend to be AI, but but they are there, right? So your phones are a powerful tool already in using this technology. It's secure by design, which is complete false. AI is nothing different from anything else. It's based around algorithms that we as humans have created. It's like any computer. Okay, it's vulnerable to attack if you don't secure it properly. You have to consider it to be yet another tool within your toolbox that you manage and secure properly. And generally speaking, AI, because you're doing things to the outside world and you're using open-to-stack technologies, it's generally open to the public, and that's good and bad. So one is very good because you get 15-year-old school kids in basements who can, much cleverer than you and I, who find vulnerabilities and can help. Okay, and then equally, they're the same ones that possibly are going to attack you. So, there's good and bad in there, but it's certainly not secure by design. You need to think about very carefully how you deliver and design these. AI is going to resolve everyone's problems. Well, once again, it's built around human algorithms, so it's only really problems that we think about now, right now. That may well change. But it's also, AI is very focused on specific problems. So what you do is you create an algorithm to fix a particular target or do something particular, and then it will go off. And even with machine learning, where it identifies and recognizes new areas and learns, it's still basically after a single goal. The concept of having a machine in a corner which you just say, ask it any question and it will give you any answer, at the moment doesn't exist. However, quantum computing might well change that. I mean, quantum computing is going to be a disruptive technology and a game changer in our world. Right now, if you think about quantum computing is, what would you do if you took your supercomputer that you have today in your factory, in your labs, and I could increase that by 1,000-fold in terms of its power, its capacity, its speed. How great would that be? Well, that's what the first iteration of quantum computing will do for you. Okay? That's how much of a game changer quantum computing will be. Google announced and then retracted a paper very recently about their quantum supremacy, and what that means is, unfortunately, it's not the take over the world supremacy. It's more the quantum computing is the point where it can do very simply something which current computer technology has no chance of achieving through power alone. So that, they released it. I don't know whether it was a PR stunt or whether it was an actual, accidental release, but that's certainly very, very close. AI is going to take jobs away from humans. Well, like I said, within research, that's definitely not the case. Our researchers see AI as a tool. Okay, it's another tool in the toolbox, and they use it in that way. In production and manufacturing, possibly that thought is there, but certainly we're changing the minds and hearts there. But what it ultimately does, it allows us to be more creative. AI is going to take over the world. Well, like I said, how? 2001? Possibly. But it needs to become self-aware, and I'm not sure if it ever will. What we need is some worldwide standards around AI to provide some security around that, and I think that's more of a political or PR issue than an actual issue, but it's still there, I think, to help people. And I'll again say it again because I was told to say it twice. So that's really what AI does for you in terms of a real application within your business. And that's all I've got. Any questions?